Welcome back, everybody, for another deep dive.
Yeah.
And today we're looking at something, well, something pretty out there.
Okay.
We're talking about wooden satellites.
Really?
Yeah. And I know it sounds like something out of, well, I don't know, some kind of Jules Verne novel. But
Right.
it turns out wood has some pretty surprising advantages when it comes to space.
Mm.
So we've got a mix of NASA research documentation
Okay.
and some online discussions that we found
Interesting.
to sort of guide us through all this.
Yeah.
So we're going to be looking at the history, the advantages, the future of wooden satellites.
Cool.
And yeah, why should we care about wooden satellites?
I mean,
well, buckle up because we're going to find out.
it's interesting, because we kind of have this idea in our heads of like,
Yeah.
what's suitable for space. And
Right.
when we think of satellites, we think of these like sleek metallic objects.
Of course.
And for good reason.
Yeah. Traditionally, they've been made with aluminum alloys
Right.
for the main structure.
Yeah.
And all kinds of different materials for the components.
Exactly.
But now we're seeing these wooden satellites,
Like LignoSat.
which is a 10-centimeter cube satellite
Yep.
made primarily of Hanuki wood.
And what's really remarkable about that is that it's built using traditional Japanese joinery techniques.
Oh, wow.
So like there's no screws or glue in the core structure.
So it's just wood fitted together.
Exactly.
That's amazing.
Yeah, it's really a testament to the ingenuity of combining ancient craftsmanship with modern space technology.
That's really cool.
Yeah.
But I guess the question is, why wood?
Yeah.
Like what advantages does that even offer?
Well, I think one of the biggest advantages is biodegradability.
Oh,
As you know, space debris is a growing concern.
yeah.
We've got all these defunct satellites and fragments
Yeah.
posing a risk to operational spacecraft.
Right.
Wooden satellites, on the other hand,
Yeah.
they completely burn up upon reentry. So that minimizes the chance of adding to this hazardous debris field.
So you're saying that metal satellites
Yeah.
don't burn up all the way?
Well, they can break apart into fragments
Oh, I see.
that linger in orbit or release harmful aluminum oxide into the atmosphere.
Wow. So that's
Yeah,
a big plus for wood right there.
absolutely. It's a win for sustainability,
Yeah.
reducing both space junk and atmospheric pollution.
So it's more sustainable and it burns up.
Right.
But is wood really that durable?
Yeah.
You know what I mean?
I know what you mean. It seems kind of counterintuitive.
Right.
Think of wood as a durable material in the harsh environment of space.
Exactly.
But that's where things get really interesting.
Okay.
While wood may seem fragile here on Earth,
Yeah.
the absence of moisture in space actually works to its advantage.
Okay.
You see, on Earth, wood absorbs and releases moisture from the atmosphere,
Right.
which causes it to expand and contract, and that leads to cracking and warping.
Right.
But in the vacuum of space, there's no moisture to wreak havoc on the wood structure.
So it doesn't have a chance to get wet and then dry out?
Exactly. It essentially becomes freeze-dried, maintaining its integrity.
Okay, so space is like a giant wood dehydrator.
That's a great way to put it.
But what about the,
Yeah.
extreme temperatures and radiation?
Right.
Can wood really handle that?
Well, the key lies in the type of wood used
Okay.
and potential treatments that are applied.
Oh.
For example, LignoSat
Yeah.
utilized Hanuki wood,
Okay.
which is known for its strength and dimensional stability.
And that worked out.
Yeah, it spent nearly a year in low Earth orbit.
Wow.
And remarkably, there was no sign of cracking, peeling, warping, or any surface damage.
Okay, so it can hold up for a while at least,
Right.
but a year is still relatively short
Yeah,
in the grand scheme of satellite lifespans.
that's true.
So what about long term?
Well, that's definitely one of the areas where further research is crucial. We need to see how different types of wood perform over longer periods.
Makes sense.
And scientists are also exploring techniques to enhance wood's durability in space.
Oh.
Similar to how we treat lumber here on Earth
Right.
to protect it from the elements.
Like pressure treated wood.
Exactly. Imagine pressure treating wood with specialized preservatives and sealants designed for the space environment.
Wow. So we're like tailoring wood
Yeah,
for its space mission.
precisely.
That's really cool.
Yeah.
I know that some people are probably still a little skeptical
Oh, yeah?
about this whole idea.
Sure.
Is this just a novelty or is there real potential here?
Well, I think the science speaks for itself.
Okay.
The research coming out of NASA and other institutions demonstrates the viability of wood in space.
Okay.
It's not about replacing all existing materials.
Right.
It's about exploring alternative options that have unique advantages.
So we've talked about, it's sustainable, it burns up,
Right.
it's more durable than we thought. But what about cost?
Ah, that's a good question.
I mean, building anything for space is super expensive.
It is.
But could using wood make satellites more affordable?
You know, our sources don't specifically address cost,
Okay.
but it's certainly a question worth considering.
Yeah.
I mean, if wood proves to be a viable and durable material for this,
Yeah.
it could potentially lead to more cost-effective satellite construction.
And if that were to happen,
Yeah,
that would really be a game changer.
it would.
Smaller organizations, research institutions,
Right.
even developing nations could start launching their own satellites.
Absolutely. It's an exciting prospect.
It is.
And it raises another interesting question.
Okay.
What else can we do with wood in space?
Like,
I mean, we've talked about its structural properties,
right,
but what about other applications?
like wooden solar panels.
Precisely.
Okay, things are getting really interesting.
Yeah.
So before we get into wooden solar panels, let's talk about this idea of electromagnetic transparency
Right.
and why that matters so much in space.
Okay. Yeah. So when we talk about wood being electromagnetically transparent,
Right.
what we mean is that it doesn't block or interfere
Yeah.
with electromagnetic waves.
Right. And those waves are really important for communication.
Absolutely. They carry the signals to and from satellites.
So for a satellite to work properly,
Yeah.
it needs to be able to send and receive those signals
Right.
without any problems.
Exactly. And that's where wood's transparency comes in.
Okay.
Unlike metals, which can reflect or absorb those waves, wood just lets them pass through.
So you could have antennas
Yeah.
inside the wooden structure of the satellite.
Precisely.
Interesting.
And that could lead to simpler designs,
Yeah.
potentially more compact satellite designs.
Right.
Instead of having antennas sticking out, you could integrate them within the body of the satellite.
Yeah, streamline the whole thing. Okay, so that kind of solves that problem.
Yeah.
Let's get back to those wooden solar panels.
Okay.
How realistic is this idea?
Right.
I mean, could we actually see wood being used to capture solar energy in space?
Well, our sources don't explicitly mention wooden solar panels being in development,
Right.
but they do highlight the ongoing research into these innovative materials for space.
Sure.
And remember, we're still really early in exploring wood's potential.
That's true.
So who knows what breakthroughs are right around the corner.
That's exciting.
Yeah.
So we could potentially harness
Yeah.
wood's unique properties
Right.
to create solar panels.
Yeah, and that would make satellites even more sustainable.
Exactly.
Using a renewable material
Yeah.
to power spacecraft that are designed to minimize space debris.
It's a really cool idea.
It's a compelling vision.
It is.
Yeah, it speaks to a more holistic approach
Yeah.
to space exploration.
Right.
One that prioritizes technological advancement and environmental responsibility.
Okay, so I think we're starting to paint a picture here
Yeah.
of why wood is so advantageous.
Right.
But I'm sure some listeners are still out there
Oh, yeah.
thinking this is crazy.
Absolutely.
Like using wood for
Mhm.
space travel.
It seems like a step backward.
Yeah, they're like, we're going back in time,
Right.
not forward.
Exactly. But as we've seen,
Yeah.
the scientific evidence,
Yeah.
it supports this.
Right.
Its durability, its biodegradability,
All right.
the electromagnetic transparency,
Yeah.
all of that makes it surprisingly suitable.
Okay, so it's not just like a publicity stunt to get attention.
Not at all.
Like there's real science behind this.
It's about expanding our understanding of what's possible
Yeah.
and exploring these alternative solutions
Right.
that might be more sustainable and in some ways even more efficient.
Okay, so let's say we've convinced everyone.
Right.
What is the future?
Okay.
What's next?
Yeah, what are the challenges?
What are the hurdles we have to overcome?
Well, one of the key challenges is scaling up production.
Okay.
I mean, right now, wooden satellites are very experimental.
Right.
LignoSat was pretty small.
Yeah.
We need to figure out how to build bigger structures.
So it's going from that small test to something that's actually functional,
Exactly.
like a full-scale satellite.
Exactly.
Okay.
And another challenge is ensuring long-term durability.
Right, because LignoSat only lasted a year.
Right.
Yeah.
And we need more data on how different types of wood hold up in space for longer periods.
Yeah.
And that's where those specialized treatments we talked about.
Oh, right, like pressure treating?
Exactly.
Okay.
Those could really be crucial.
And then there's the research into new materials and fabrication techniques.
Absolutely.
You mentioned earlier NASA's looking into these digital materials.
Right.
Can you talk about that a little bit more?
Yeah, so digital materials are essentially materials whose properties can be programmed. Yeah.
At a microscopic level?
So you can fine-tune them.
Exactly. You can fine-tune a material's strength, flexibility,
Okay.
even its response to temperature or radiation.
That's incredible.
Yeah.
It's pretty amazing.
So we could potentially engineer wood
Yeah.
to make it even more durable
Exactly.
or to give it specific functionalities
Yeah.
for space.
Precisely.
That's mind-blowing.
It's like we're on the cusp of a materials revolution
Yeah,
in space exploration.
it really seems that way.
Yeah.
But I guess with any new technology,
Right.
we have to look at the big picture.
Absolutely.
What are the implications here?
Yeah. What happens if this really takes off?
If everyone starts using wooden satellites?
Well, one of the most exciting prospects is the potential
Yeah.
for democratizing access to space.
Okay, what does that mean?
So if wooden satellites
Yeah.
are more cost-effective to manufacture,
Right.
it could lower the barrier to entry
Okay.
for organizations
Yeah.
or even individuals who want to launch their own spacecraft.
So you're saying like universities,
Yeah,
research institutions,
absolutely.
startups could all have their own satellites.
Exactly.
Wow.
Imagine that.
That's incredible.
Yeah, more eyes on the universe,
Hmm.
collecting data, conducting experiments.
Pushing the boundaries of knowledge.
Exactly.
That's a really exciting thought.
It is a tantalizing vision,
It is.
and it highlights how these seemingly simple innovations can have far-reaching consequences.
Right. But we also need to be realistic
Yeah,
and acknowledge that there could be some challenges.
of course.
And we want to make sure that this is developed responsibly.
Absolutely.
So what are some of the concerns?
Well, one concern is the potential for unintended environmental consequences.
What do you mean?
Even though wooden satellites are biodegradable,
Right.
we need to carefully study
Yeah.
that reentry process
Okay.
to make sure it doesn't release anything harmful.
So just because it's natural doesn't mean it's automatically safe.
Exactly. We need to do our due diligence.
Okay.
Another thing to consider
Yeah.
is the impact on existing industries
Right.
and workforces.
Yeah. If everyone starts using wood,
Right. What happens to the people who
Yeah.
build traditional satellites?
Exactly.
So we need to anticipate those changes
yeah,
and plan for a just transition.
make sure no one gets left behind
Exactly.
as we move forward.
Technological innovation should always be guided
Right.
by ethical considerations
Yeah.
and a commitment to social responsibility.
It's not just about the technology itself.
It's about how it impacts people
Right.
and the planet.
Okay. Well, this has been a really fascinating conversation.
It has.
We've learned a lot about the technical aspects,
Right.
the potential benefits,
Yeah.
and now the broader societal
Let's
implications.
barely scratch the surface.
I know there's so much more to talk about.
There is.
But for now,
Yeah.
we're going to have to wrap up this part
Okay.
of our deep dive.
Sounds good.
But there's one more fascinating aspect of wooden satellites
Oh, yeah.
that we haven't talked about yet.
You're talking about the radiation shielding.
Yes,
Okay.
that's right.
Let's get into that. All right. So we're back.
Back for more on these wooden satellites.
That's right.
We've talked about their durability, the potential for solar panels, even digitally engineered wood.
Right.
But now let's talk about radiation shielding.
Yeah. This is where things get really interesting.
I mean, you think of radiation shielding.
yeah.
You think of lead.
Heavy metals, right?
Yeah. So how can wood possibly protect against radiation?
Well, it's amazing how nature often has solutions
Right.
that we might not even think about.
Yeah.
So, yeah, lead and other dense materials are great at blocking radiation,
Right.
but wood, with its unique cellular structure,
Yeah.
can actually scatter and absorb certain types of radiation.
So it doesn't stop it completely?
Right. It's not like a wall, it's more like a maze.
Okay.
The radiation particles get bounced around.
They lose energy.
Mm.
And that combined with wood's ability to absorb some of the radiation
Yeah.
can provide a certain level of protection.
So wood is like a natural radiation shield.
It really is.
That's incredible.
And scientists are actually researching this.
Really?
Yeah, they're exploring the use of wood-based composites
Yeah.
for radiation shielding in spacecraft.
So this isn't just theoretical.
No, they're actually
Okay.
building and testing these things.
Wow.
Especially for those long-duration space missions.
So like missions to Mars
Exactly. You need to protect the astronauts
Yeah.
from all that radiation.
for years.
Right. And these composites can be engineered
Yeah.
to be lightweight and sustainable.
And still provide that protection.
That's the
So imagine a spacecraft
yeah.
with a wooden hull
It's like a giant wooden spaceship.
that not only holds everything together,
Provides structural integrity.
but also shields against radiation.
That's the idea.
That's amazing.
It's like a bio-inspired design. Yeah. Taking inspiration from nature.
Exactly. Nature has had millions of years
Yeah.
to perfect these materials.
It's pretty incredible.
It is.
To think that something as simple as wood
Yeah,
could be so important
right.
for the future of space travel.
We're just starting to scratch the surface.
So this deep dive has definitely opened my eyes.
I'm glad to hear that.
I had no idea wood was so versatile.
It's amazing what you can do with it.
Yeah, and who knows what the future holds.
The possibilities are endless.
Well, that's all the time we have for today.
Okay.
But I want to thank you for joining us
It was my pleasure.
and for sharing your expertise on this fascinating topic.
Anytime.
And to all our listeners out there,
Yeah.
keep looking up
Keep exploring
and never stop questioning.
and keep an open mind.
That's right, because you never know where innovation might come from.
Exactly.